Today, we'll be looking at volume. Objectives for today's lesson will be calculate the volume of solids, prisms included cube, cuboid, and cylinder. What is volume? Volume is the amount of space that a substance or object occupies, or that is enclosed within a container. How to calculate volume? Let's look at ways of calculating volume. Now, volume has unit cube as its unit of measure. This means that for each solid, 3 dimensions of that solid must be used to calculate volume. Dimensions. What is dimension? Dimension refers to a measurement of length in one direction. And these are the examples: width, depth, radius, and height. Therefore, in the literal sense, volume is actually filling the available space a polyhedron has with unit cubes. Polyhedron. A polyhedron is a three-dimensional object with flat polygonal faces, straight edges, and sharp corners or vertices. So if we pay attention to this animation for a minute, you will see that this polyhedron actually came from the packing of unit cubes together. Please notice the construction of that. So each cube is considered a unit cube, and if you realize they are packed together to form a polyhedron or a solid. In that case, it's a cube, a larger cube that it actually designed. So if we are to count these unit cubes as they're stacked, we will know the volume of this larger cube. Did you count? I counted 8. So actually 8 unit cubes can be contained in this solid. Hence, the volume of the large cube is 8 cubic units. Let's now look at a cube. A cube is a symmetrical, three-dimensional, box-shaped solid object that has 6 square-shaped faces. And not just 6, but 6 identical square-shaped faces. Can you make out the 6 from this image? Now, let's look at how we calculate the volume of a cube. The dimensions of a cube are length, width, and height. However, we must pay attention to this. However, all three dimensions are the same if we look at the diagram. Therefore, each dimension is considered a side, labeled S. To find the volume of a cube, all you need to do is to find the product of the three dimensions. Let's look at a scenario. Here we have a box. I wonder what this scenario is all about. Karen wanted to package some items to send to a friend. The box she used had dimensions as seen in the diagram. Please pay attention to the dimensions there. What is the volume of the box Karen used? Given the three dimensions of the box are equal, yes, they were. This is how we would approach the volume. All we have to do is to multiply the three dimensions by themselves. Hence, the volume of the box is 40 centimeters multiplied by 40 centimeters multiplied by 40 centimeters. And the product of those three numbers will give you 64,000 cubic centimeter. And that's the volume of the box. Now on to a cuboid. A cuboid is a box-shaped solid. It has 6 flat faces that are rectangular. Now to calculate the volume of a cuboid, these are the things that we need to pay attention to. The dimensions of a cuboid are length, width, and height, and breadth in some cases. To find the volume of a cuboid, all you need to do is find the product of the three dimensions. Let's look at a scenario. Tommy wants to pack as many Rubik's cubes as possible into a box. And of course, there's a diagram of a Rubik's cubes. He has two options as shown in the diagram. And these diagrams are not drawn to scale, right? Pay attention to the dimensions of these boxes. You'll need to use them in your calculations going forward. If each Rubik's Cube has sides of length 5.7 centimeters, pardon me, which box should Tommy choose to pack more Rubik's Cubes in? So basically, Tommy wants to pack as many Rubik's Cubes as possible into a box. But we need to now determine which of these two boxes would allow Tommy to pack as many Rubik's Cubes. Let's look at the approach. Step 1. Let us calculate the volume of one Rubik's Cube. How do we go about doing that? Alright, so the Rubik's Cube, as the name suggests, is a cube with all the dimensions equal in length. So When we do the substitution, we have 5.7 centimeters being multiplied 3 times by itself. The volume of the cube, after finding the product for those 3 lengths, is 185.193 cubic centimeters. Step 2. Calculate the volume of each box. Okay, so let's look at box 1. These are the dimensions for box 1. And if we pay attention to the box, we realize that the dimensions are not the same. They are not equal. Hence, we will need to look at this formula to calculate volume. Length times width times height. Of course, when we substitute, we get 28.5 centimeters multiplied by 45.6 centimeters multiplied by 34.2 centimeters. When you find the product of those 3 numbers, you get 44,446.32 cubic centimeter. So that's the volume of box 1. Still at step 2, we need to now find the volume of box 2. Volume of box 2 would be length times width times height. Of course, the dimensions of box 2 is 39.9 centimeters, 28.5 centimeters, and 57 centimeters. When we multiply those 3 numbers, we get the volume of box 2 to be 64,817.55 cubic centimeters. Step 3 in our approach. Calculate the number of Rubik's cubes in each box. How do we do that? Well, for box 1, in order to know the number of Rubik's cubes, we need to divide the volume of box 1 by the volume of one single Rubik's cube. Let's see. That would be 44,446.32 cubic centimeters divided by 185.193 centimeter cube or cubic centimeters. Our result will be 240 Rubik's cubes. So that means that for box 1, 240 Rubik's cubes can hold in that box. Let's see what transpires. It's the same approach. Number of Rubik's cubes equal volume of box 2 divided by volume of one Rubik's cube. That is 64,817.55 cubic centimeters divided by 185.193 cubic centimeters. When we divide, we find that box 2 can hold up to 350 Rubik's cubes. Conclusion: Tommy will need to choose box 2 if he wishes to pack more Rubik's cubes. Onto a cylinder. So a cylinder is a three-dimensional closed solid that has two parallel, usually circular bases connected to a curved surface. If we pay attention to this animation, it will show us exactly how a cylinder is designed. Now, calculating the volume of a cylinder. If you pay attention to this diagram, you realize that the dimensions of a cylinder are slightly different from the dimensions of a cube or a cuboid, in which the dimensions are named differently. So the dimensions of a cylinder are length or height and radius. Now, of course, we know that radius comes about when there is something circular. There's a circular face involved. In this case, we find the product of the area of the circular face and the height or length. Now for scenario. Right, so Auntie Donna wants to pack a barrel filled with items to send to Jamaica from America. She needs to know the volume of the barrel. Calculate the volume of the barrel for Auntie Donna. Now pay attention to the dimensions that are there for the barrel. Approach. So we've designed this little volume formula to calculate the volume of the barrel, and that is area of this circular face multiplied by height. Of course, we incorporate pi in finding the area of the circular face, and of course pi is 22 upon 7 multiplied by 11 inches all square. Right? Remember, the area of any circular object or circle is pi r square. So it's basically finding the area of that circular face, then multiplying by the height of the barrel, which was 34 inches. Now, in calculating the volume, what we can do is multiply 22 by 11 by 11 by 34, then divide that product by 7. Your response, your answer will be 12,929.71 cubic inches. And that's written to 2 decimal places. Now on to a cone. Okay, so let's look at a cone. A cone is a distinctive three-dimensional geometric figure that has a flat surface and a curved surface pointed towards the top. The pointed end of the cone is called the apex, whereas the flat surface is called the base. Calculating the volume of a cone. Let's see. The dimensions of a cone are length or height and radius. These two dimensions are perpendicular to each other. Please note, perpendicular at right angle at 90 degrees to each other. In this case, we find 1/3 the product of the area of the circular face and the height or length. Now from this diagram, do you see slant height? No, it's not the slant height, but it is the height that is perpendicular to the radius. Please note. What does the cone and cylinder have in common? Please take a look at this animation. That's a cone being put into a cylindrical object. Another one. Another one. So please note that if you pay keen attention, a cone with the same radius and height as a cylinder will fill 1/3 of that cylinder. If you realize each time a cone is placed within this cylinder, it occupies 1/3 of the cylinder. Yes? See? 1/3. One cone, 1/3. Another cone, 2/3. Another cone fills that cylinder. Okay. Scenario. An ice cream shop wants to know the volume of a new brand of cones they bought. Calculate the volume of the cone shown in the diagram. Approach. The volume of a cone is 1/3 times the area of the circular face of that cone times the height, which is perpendicular to the circular face. That is 1/3 times 22/7, which is pi, times 3.5 centimeters square, all square, that's the radius, times 15 centimeters, that's the perpendicular height. Of course, we found what the area of the circular face was by multiplying pi times r times r. We arrive at 38.5 centimeters square, or square centimeters. Then we find the product of 38.5 centimeters squared and 15 centimeters. That gives us 577.5 cubic centimeters. Then all we have to do now to find the volume of a cone is to find 1/3 of that amount, which will give us 192.5 cubic centimeters. Okay, we are now on to a sphere. A sphere is a round solid figure, or its surface with every point on its surface equidistant from its center. Oh, How to calculate the volume of a sphere? Now, the sphere has only radius as its dimension. Therefore, in this case, we find 4/3 the product of the area of the circular face and the radius. Now for a scenario. A standard size 5 football has a radius of 11 centimeters. What is the volume of the ball? Let's look at the approach. Please note the volume formula for any sphere. The 4/3 the area of the circular face times the radius. To substitute, of course, we use pi as 22/7 for this calculation. Radius is 11 centimeters for the ball. Okay. Now what I did was to find the area of that circular face. And that is multiplying pi by 11 centimeters and by 11 centimeters. You get 380.286 square centimeters. Then I multiplied that 380.286 by 11 centimeters, arrived at 4,183.143 cubic centimeters. But the volume of the ball is not found until we find 4/3 of that amount, which will give us 5,577.524 cubic centimeters. Onto the triangular prism. A triangular prism is a polyhedron made up of 2 triangular bases and 3 rectangular sides. By the definition, the 2 triangular bases are parallel and congruent to each other. How to calculate the volume of a triangular prism? The dimensions of a triangular prism are length, base, height. And please remember, the height that we're talking about is the perpendicular height. To find the volume of a triangular prism, all you need to do is to find the product of the triangular face and length. Scenario. A block in the form of a triangular prism was cut from wood to be used by a carpenter to complete a piece of furniture. What is the volume of the block? Approach. The volume of the block will be the area of the triangular face times length. Of course, its triangular face has area half times base times height. Then we need to multiply by the length. So in substituting, it is half times 3 centimeters times 4 centimeters times 11 centimeters. That will give you the volume of the block. All I did was to find the product of 3 centimeters, 4 centimeters, and 11 centimeters. That gave 132 cubic centimeters. In order to find the volume of the block, we'll find half of that amount. That will give us 66 cubic centimeters. Conclusion. Volume involved fitting unit cubes in a three-dimensional object. Three-dimensional objects are also called polyhedrons. In order to calculate volume, the three dimensions of a solid must be considered. And this would be the end of another presentation on volume.
Much for me, much for you, that. Look how hard me I work, oh God. Now feel much me work so hard.